Welcome students to the solving session for the October 2024 IAL Pure Mathematics paper 2. We will start off with question 1. Well, it says that, let me get my pencil. Right. So question 1 says a continuous curve is equation y equals fx, and this is the table given, and using the trapezium rule with all the values of y in the given table from this table, by using trapezium rule we have to find the estimate for the integration of this function, right? Okay, so for a we know that the equation for trapezium rule, right, trapezium rule is 1 by 2 h y naught plus yn plus 2 times y1 plus y2 plus y3 and so on, and then bracket closes, right? This is the equation. So for this math, the h value, the height, would be the difference between the x values, right? So here we can see that the difference between the first and second value is 1.75 minus 0.5 equal 1.25, right? And similar for this, the difference between 1.75 and 3 is 1.25, and so on. So we have our h. Therefore h is 1.25. okay, now y naught is the very first value of y, and yn is the last value of y, and in the middle values, the values in between will be summed up and then multiplied by 2 and then added together. Therefore we can find out the integration from 0.5 to 5.5, right? From 0.5 to 5.5, f of x dx will be equivalent to the value of this 1 by 2 times the value of h is 1.25, and y naught is what? Y naught is 3.479 plus what? Yn is 5.182, so 5.182 plus 2 times the summation of these three values, so 6.101 plus 7.448 plus what? 6.823. Okay, now equating this gives us, if we put it into calculator, this will give us 9881 divided by 310, and therefore it's equivalent to 30.9. This is our answer. Now coming to B, using your answer to part A, so we will use this value, and making your method clear, estimate the value of this, right? Okay, so we can write integration of 0.5 to 5.5 f of x plus 4x. So since there is a plus in between, we can differentiate the, not differentiate, we can write them separately. We can write them as separate integrations. 0.5 to 5.5 f of x is this one, f of x dx, plus again the integration from 0.5 to 5.5 of 4x dx. Now we already know the value of this, right? We already know the value, which is 30.9 plus, now the integration of 4x would be 4x squared divided by 2, and the limits are 5.5, upper limit is 5.5 and lower limit is 0.5. And if we calculate this, 30.9 plus 2x squared, 5.5 and 0.5, and this gives us a value of 90.9, and that is our answer. Moving on to question 2, we have this. Now a sequence of numbers u1 and u1, u2, u3 is defined by this, that u1 is 7 and u n plus 1, that means any value from greater than n would be minus 1 to the power n, basically this equation. So whereas k is a constant, okay, so show that u5 is 7. Okay, we have to show that u5 would be 7. So we know that u1 equals 7. Therefore u2 would be, since n plus 1, so minus 1 to the power what? N was 1, right? So 1 un, which was 7, plus k. That would be minus 7 plus k. Or we can write it as k minus 7. You understand? Like if we so since this is 2, therefore if we consider it as 2n plus 1, therefore n would be u1. Therefore the value of u1 was 7, which is why we input the value of 7 in place of un. Then u3 similarly would be minus 1 square. The value of u2 was k minus 7, so k minus 7 multiplied with minus 1 square plus k, that equals k minus 7 plus k, so 2k minus 7. Similarly, you can find out u4, which would be minus 1 cube 2k minus 7 plus k equals, so since minus 1 cube is minus 1, therefore 7 minus 2k plus k equals what? 7 minus k. And finally u5 will be minus 1 to the power of 4, 7 minus k plus k equals minus 1 to the power of 4 is only 1, so 7 minus k plus k, it gives us the result of 7. Therefore we have shown that u5 is indeed 7. Now given that the summation of u to the ur from r to the value of 1 to 4 will be equal to 30. Now find the value of k. Okay, so we need to add the values of u from starting from 1 to r. Therefore for b, this was a. For b, we just add all these values. So u1 was 7 and u2 was k minus 7 plus u3 is 2k minus 7 plus u4 is 7 minus k, and all the values total gives us 30. There you go. So 7 minus 7 cancels out, this minus 7 plus 7 cancels out, and this k and minus k cancels out. Therefore we're left with 2k equals 30. Therefore k equals 15, and this is our answer. Then moving on to question C, we have that hence find the value of r from 1 to 150, the summation of all those values. Okay, for this is a tricky question because since this is a very huge number, we cannot calculate up to that value. But here we can see that we have a sequence, right? We have a sequence. For u1 we got 7, but at the end of by the term u5, but by the fifth term we got a repeated answer of 7. And if we continue in this way, like for u6, u7, u8, we will see that u10, the 10th term will be 7 again. That means, so we can see that this is 7, the next term was what? K minus 7, right? K was 15, so 15 minus 7 is what? 8. And then the third term would be 2k minus 7, so 30 minus 7 gives us 23. And the fourth term was 7 minus k, so 7 minus 15 gives us minus 8, right? And then we have again 7. So this whole thing it repeats here again, right? So after every, how many terms? So 1, 2, 3, 4. After every 4 terms, the sequence is repeated. Okay. Therefore, we can find out that how many 4 terms, how many like this 4 pairs do we have in 150, right? So you can just find out by dividing 150 by 4, and that gives us what? Let me just do this. 150 divided by 4 is 37.5. So 37.5. That means we have 37 pairs of four these four sequences, right? So we have 37 pairs. Therefore, we also, but 37.5 refers that we have two values more than 37, right? So there will be 37, 7, 8, 23, and minus 8s. But plus, we will have two more values. So the next, basically the next iteration will begin with 7. Therefore, the 38th iteration will begin with 7. So 7, and then another value which is 8. So these two will be left out since these are not forming a pair. That means the summation of the 150th term would be this value, right? So we just sum all this, right? This wouldn't be a plus, this will be a minus. So here was a minus. Therefore 37 times 7 plus 8 plus 23 minus 8 gives us what? Okay, I'll just write the answer directly. I'll just use my calculator, and this gives us 1125. Okay, there you go. That is our required answer. Moving on to question 3. So here we have a function like a polynomial where a and b are integers, given that when f of x is divided by x plus 3, the remainder is 55, and show that this is the relation between a and b. This is easy, so we just put f of negative 3. So in case when something is divided, when a polynomial is divided by another polynomial, what do? We just do x plus 3. This divisor will be equal to 0. Therefore the value of x will be minus 3, and we input this value of x into the function. So 2 minus 3 cubed minus 3 square minus 3, sorry, this is not plus. We have, okay, let me rewrite this as well. So minus 3 square minus 3a plus b, and what we have, the remainder is 55. So in place of f of minus 3, we write 55 equals 3 cubed is 27, and since it's negative 3, so minus 27 times 2. 3 square is 9, so minus 9 minus 3a plus b equals 27 times 2 is 54, right? So 54, so we can just put these values here. Therefore, or 55 plus 54 plus 9 is equal to minus 3a plus b, right? Or this value in total is what, 118 equals minus 3a plus b, and if we just take minus common, we can move this minus to here. So minus 118 equals to 3a minus b shown. There you go. Okay, then given that 2x, given also that 2x minus 5 is a factor of x. Okay, fine. Since this is a factor, so 2x minus 5 for b, I find the value of a and the value of b. So 2x minus 5 is a factor, therefore 0. Therefore we put the value of x as 5 over 2, and if we input this value 5 over 2 into the function of f, we get 5 over 2 cube minus 5 over 2 square plus 5 over 2a plus b, right? And this gives us 25 plus 5 by 2a plus b, and since this is a factor, so the remainder is 0. So we have two equations now, like this is equation 2, and we can consider this as equation 1. Now solving these two equations, you can solve this at two simultaneous equations. I'm gonna just do the I'm just gonna find the value of b and then put the value of b here. So or 0 equal to 25. So from here we can see If I change my color of the pencil, from here we can see that b will be equal to 3a minus plus, so 3a plus 118, and we can input the value of b here. So 5a 25 plus 5 by 2a plus the value of b is what, 3a plus 118, and simplifying this will give us 11 by 2a equals minus 143, and therefore a is minus 26. And we can also find the value of b from this equation. So 3 times minus 26 plus 118 gives us 40, and these are my answers. Then C tells that hence find the quotient when f of x is divided by x minus 7. Okay, so we have to divide the polynomial of x by x minus 7. So for C, we do long division. X minus 7, and f of x was 2x cubed. What was f of x? I forgot. So 2x cubed minus x squared. The value of a is minus 26. So plus x minus x squared minus 26x plus 40. So here minus x squared minus 26x plus 40. Okay, so we just now what do you need to multiply with this to get 2x cubed? We just multiply 2x squared. So 2x cubed minus 14, 7 2s are 14x squared, minus plus the sign changes since we are doing subtracting. This cancels out. So 14x squared minus x squared is 13x squared, and we put this value here, 26x. Now what you need to do to get this value from here, we just multiply with 13x, therefore 13x squared, and minus 13 times 7 is what? 13 times 7 is 91x, minus plus we have this 2 cancels out. 91 minus 26 would be, wait a second, let me calculate first. 91 minus 26 is 65. So 65x, and this plus 40 comes down. Now we just need to multiply with 65 to get 65x minus 65 times 7 is, wait a second, 65 times 7 is 455 minus plus. Okay, so the remainder is 455 plus 40 plus 40 gives us 495. Therefore our quotient, we don't have to find the remainder, we just have to find the quotient. Therefore our quotient is this value. So q of x is what? 2x squared plus 13x plus 65. This is our answer. Okay students, I will see you in the next video beginning with question 4. Welcome students. Now we will start from question 4. So for a the curve C has equation this, and a tells us to find dy by dx, giving each term in simplest form. This is easy. So y equals 4x half plus 9x minus half plus 3. Therefore dy by dx, which is differentiated once. So 4 times 1 over 2 x 1 by 2 minus 1 plus 9 times minus 1 by 2 x minus 1 by 2 minus 1, and 3 becomes 0. So this is 2x 1 by 2 minus 1 is minus 1 by 2 minus 9 by 2 x minus 1 by 2 minus 1 is minus 3 by 2, and that is our answer. But if you do simplify this further, you can write 2 root x minus 9 by 2 root x cube. both are similar. B, hence find the x-coordinate of the stationary point of C. So to find stationary point, we just take the differentiation to be 0. That means, say this is the curve, so the stationary point will be at here, right? And at this point the gradient is 0. So since dy by dx, or the differentiation, is the gradient, so we take the gradient to be 0. So we found this, the gradient. So 2 by root x minus 9 by 2 root x cubed will be equal to 0. Or if I take root x as common, we can write 2 by 1 minus 9 by 2. So 3 by 2 divided by 1 by 2 is 1, if I'm not wrong. Yeah, 2x equals to 0. What did we do? We took root x to be common. So since we took root x common, here it remains 1, and here, since x, this is x3 by 2 divided by x1 by 2 gives us x3 by 2 minus 1 by 2 equals x to the power of 1. Or 2 equals 9 by 2x, or 4x equals 9. Therefore x equals 9 over 4. That is the answer. Now C1, find d square y by dx square, giving each term in simplest form. Okay, C1, for C1 we have to differentiate this value once more. So for our better understanding, we can write this value. Therefore dy by dx was 2x minus 1 by 2 minus 9 by 2 x minus 3 by 2 equals to, so d square y by dx square, we will differentiate this further. So 2 minus 1 by 2 x to the power minus 3 by 2 minus 9 by 2 times minus 3 by 2 x to the power minus 5 by 2, and this gives us minus x to the power minus 3 by 2 minus 27 by 4 x to the power minus 5 by 2. Okay, this is our value, answer. And then hence determine the nature of the stationary point of C, giving a reason for your answer. Okay, so to find the nature, what do? We just put the value of x that we found for our stationary point, this value of x, in this equation. Therefore d square y by dx square will become minus 9 by 4 to the power of minus 3 by 2 minus 27 by 4, 9 by 4 to the power of minus 5 by 2. So this becomes minus, this is 3 square, this is 2 square, so 3 to the power minus 3 by 2 to the power minus 3 minus 27 by 4, and this is 3 to the power of minus 5 divided by 2 to the power of minus 5. And doing this, we get 16 divided by 27. Now this clearly is a positive value. This is greater than 0, which is a positive value. And if we get the value of d square y by dx square to be positive, that means the point is a minimum point. Therefore the point is minimum. Since this value is greater than x, if it were to be negative, if it were to be less than 0, then the point would have been maximum. But here it's minimum. Next question, 5a. Find in terms of a the first three terms in ascending powers of x of the binomial expansion of this. This is easy. We know the formula. So 2 plus ax to the power 6 will be 2 to the power of 6 plus wait, let me recall the formula. So 2 plus ax to the power of 6 equals 2 to the power of 6 plus 6c1 2 to the power of 5 ax plus 6c2 2 to the power of 4 ax whole square plus 6c2 2 to the 2 cube ax cube to the power of cube, and it goes on. Okay, we just need 3 terms. So this is our first term, second term, and third term. We don't even need this value. This gives us 2 to the power of 6 is 64, plus putting this into calculator gives us 192 ax plus this value gives us 240 a square x square plus dot 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 dot. This is our answer. Now this is another function that is given that the constant term in the expansion of f of x is 576. So constant term means there is no x there, which is pretty much similar to x to the power of 0. So we need to find the term that doesn't contain any x values or any x variable, and that would be, the coefficient of that would be 576, and we need to find the value of a. This is easy. We just expand this function too. So 3 plus 1 by x whole square would be, we just put in the formula for a plus b whole square. So 3 square plus 2 times 3 times 1 over x plus 1 over x whole square equals 9 plus 6 over x plus 1 by x square. Now multiplying both of this and this will give us 3 plus 1 over x whole square and 2 plus ax to the power of 6 will be equal to 9 plus 6 by x plus 1 by x square into 64 plus 192 ax plus 240 a square x square. Now if we multiply each term, we will find that some of these values, some of the results will not contain any x. So that is only our concern. Our concern is to find the constant terms where there is no x variable. So terms with constant values are what? Look, this is a constant value, this is a constant value. We can multiply this and we'll still get a number, a constant value. Then this is 1 by x, and if we multiply this with this, the x and x cancels out and we get a constant value. Similarly for this one, this x square and x square, multiplying both of them cancels out the x squared. Therefore we can do 9 times 64 plus 6 by x times 192 ax plus 1 by x squared times 240 a square x square, and this total sum would be equal to what was given, 576. Or so this is 9 times 64 is 570. No, wait. So 9 times 64, if we take the calculator, we get, 9 times 64 is 576 plus 6, this x cancels out, and here x square cancels out. So 6 times 192 times 6 is 1152 1152a plus 240 a square will be equal to 576, or 240 a square plus 1152a equals 0, or a common. If we take a as common, then 240 a plus 1152 will be equal to 0. So from here we get that it's either a equals 0 or 240a plus 1152 equals 0. Therefore a equals minus 1152 by 240, and dividing them gives us minus 24 by 5. That is our answer. Also keep in mind that we cannot put the value of a as 0. This will not be 0, because if this is 0, then 2 plus ax, this whole term becomes 0, and the binomial expansion is no longer valid. Okay, before moving on to the next question, I think I skipped a part on the previous question here. So I skipped this part. So D said that state the range of values of x for which y is decreasing, right? For which y is decreasing. That means, look, if we plot the graph, of y, the value was minimum, right? So the curve will be like this, like a U shape, right? So like this, right? And we know that at the minimum point, the coordinate of x was what? The coordinate of x was 9/4. So this value was 9/4. This is the x-axis and this is the y-axis. Therefore, the value of the graph is decreasing when it is decreasing below the x value of 9/4. So below x less than 9/4, the value of y is decreasing. And we were given the domain that x was greater than 0. So that means this part is unnecessary. This part does not exist. So the graph actually starts from here. Therefore, we can tell that the range is from 0 to 9/4, because after 9/4, so proceeding forward from 9/4, we see that the graph will be increasing. It's only decreasing below from 0 to 9/4. Next, for question C, using the laws of logarithm, solve this. So here we have given log 4 12 minus 2x equals 2 plus 2 log 4 x plus 1. What we can do here, we can just bring the logs at one side. So log 4 12 minus 2x minus 2 log 4 x plus 1 equals 2, or log 4 12 minus 2x minus this 2 we can write it as the power of this value. So log 4 x plus 1 whole square equals 2. Now since we have a minus with subtraction between two logs, so we can just divide these two terms. So log 4 12 minus 2x divided by x plus 1 whole square is equal to 2. Now we can break down the log. So 12 minus 2x plus x plus 1 whole square becomes 4 square. This will be equal to 4 square, or 16. 4 square is 16. 16 x plus 1 whole square is equal to 12 minus 2x, or 16 x square plus 2x plus 1 equals to 12 minus 2x, or 16x square plus 32x plus 16 minus 12 plus 2x equals 0, or 16x square plus 48x 32 plus, oh no, I made a mistake, 32 plus 2x would be 34x, and 16 minus 12 is plus 4 equal to 0, or we can take 2 common. So 8x square plus 17x plus 2 equals 0. Now if we want to find the value of x, we can see that this doesn't give us middle term breaks. We have to use the quadratic equation formula, which is x equal to minus b plus minus root over b square minus 4ac all divided by 2a. Here b is 17, so minus 17, wait, minus 17 plus minus root over 17 square minus 4 times a is 8 times c, which is 2. Okay, so this is 2 divided by 2 times 8, and this will give us the value. Solving this into 4, so we take, okay, let me write it again. So x will be equal to either it's minus 17 plus root over 17 square minus 4 times 8 times 2, 4 times 8 times 2 divided by 2 times 8, or x will be equal to minus 17 minus root over 17 square minus 4 into 8 into 2 divided by 2 into 8, and therefore we have this will be equal to this will be equal to minus 1 by 8, and this will be equal to minus 2, right? So that is our answers. Okay. Okay, students, I'll see you in the next video. Question 7 for the P2 paper of 2024 October. So 7 says Jem pays money into a savings scheme A over a period of 300 months, right? Jem pays £20 into scheme A in month 1 and £20.50 in month 2 and 21 in month 3 and so on, so that the amounts Jem pays each month form an arithmetic sequence. So from here we can see that the sequence increases by 50 cents, right? So 0.50, the increment is always 0.50 pounds, right? Okay, so we have to show that that Jem pays 69.50 into scheme A in month 100, right? So for arithmetic progression, we know the formula for the nth term, right? Nth term, this is A, nth term of an arithmetic progression is a plus n minus 1 times d. Now what is a? A is the initial value, which is for here it's 20, and d is the difference between each value, between each term, so that is 0.50. If we just put in the values here, so a is 20 plus n was 100, so it will be 99 times 0.50, and if we calculate this, it will give us the value 69.5. That was what we were supposed to show, so shown. Now for B, it said find the total amount that Jem pays into scheme A over the period of 300 months. Okay, so we need to find the total sum. The equation for S of n is n by 2, 2a plus n minus 1 times d. You have to memorize these formulas, or maybe it's given in your data booklet. So here n is 100, right? No, it's not 100, it's 300, right? 300, so over 300 months. So n is 300 over 2, and 2 times what? 20, right? 2 times what is a? A was 20. So 20 plus n minus 1, which is n is 300, so it's just 299 times 0.5. So this is 150, 40 plus 299 times 0.5. And if we calculate this in our calculator, so 40 plus 299 times 0.5 times 150 gives us the value 28425. 28425 pounds. This is our answer. Then it says that Kim pays, another person Kim, pays money into a different savings scheme B over the same period of 300 months. But here the scheme B increases by the same percentage each month, so that Kim pays each month from as a geometric sequence. Okay, so the previous one was arithmetic sequence, now it's a geometric sequence. So for Kim, he pays 20 pounds in month 1, and in month 300 he pays 250 pounds. So we use the model to calculate to the nearest 10 pounds the difference between the total amount paid into scheme A and the total amount paid into scheme B over the period of 300 months. So we have to calculate the difference. So for that, we already know the total amount paid for scheme A. Now we have to find the total amount paid for scheme B. So we already know that scheme B is a geometric progression. So for the nth term of a geometric progression, the formula is a r to the power n minus 1. Okay, so we know that a is 20. So the nth term, which was like 250 for 300th term, that is the nth term. So 250, right? 250 is the nth term, and this is 20 r to the power n was 300. Therefore 300 minus 1 is 299. So from here we can find the value of r. So r is 250 divided by 20 and root over to the power of 299, right? Okay, this is our r, the required value. Now keep in mind that r needs to be greater than 1, and if we calculate this is greater than 1. Therefore we can find the total sum. So the formula for a geometric progression for s of n is a r to the power n minus 1 all divided by r minus 1. So putting the value, a is 20, r to the power n would be this to the power of 300, right? So 299, 250 divided by 20, and the whole thing is to the power of 300, and this minus 1 whole divided by r minus 1. R is this 299, 250 by 20 minus 1. Now if you do this with your calculator, you will find that the value is 27362.94829 pounds. So we have to find the difference to the nearest 10 pounds. So we can write it. So this is equivalent to 27360. Therefore the difference is, which one is greater? This is greater, right? So 28425 minus 27360. Now calculating this gives us 1060, equivalent to 1060, and that is our answer. Alright, moving on to the next question. Question 8. Now here we are given a graph. Figure 1 shows a sketch of part of the curve C1. So this curve, this curve which is increasing is C1, and the decreasing curve is C2, with equations. So we are given both the equations of these two curves, and the curve C1 and C2 intersect at the points P and Q as shown in figure 1. So yep, here at P and Q. Now A says use algebra to find the x-coordinate of P and the x-coordinate of Q. So we have to find this x-coordinates, right? This x-coordinates. So for us to find these two coordinates, we just need to equal these two equations. So here they both intersect. That means here both the equations will give the same value of x. Therefore we can just make these two equations equal to each other. Therefore we can write x squared plus 3 equals to 13 minus 9 over x squared, or x squared plus 3. What we can do is we can do it a different way. We can use, for simplification, we can write x squared plus 9 over x squared equals 10, and or this is x squared, so this will be x to the power 4 plus 9 equals 10, and we can write x to the power 4 minus 10x squared plus 9 equals 0. So in place of x we can write z, so z is x squared, so or z squared minus 10z plus 9 equals 0, or z squared minus middle term break, for 9 ones are 9, so we can write 9z minus z plus 9 equals 0, or z, if we take z common, z minus 9 minus 1 common, minus 1 common, and we have z minus 9 equals 0. So we can write that z minus 9 and z minus 1 is equal to 0. Therefore z is 9 and z equals 1. So we knew that z was x squared, so we can write x squared is 9. Therefore x equals 3, plus minus 3 actually, but since the graph is in the positive side of the x-axis, we can just write that it is equal to only positive 3. Here x squared equal to 1, therefore x equal to positive 1. That means our coordinate, x coordinate for p is 1, and so x coordinate for p is 1 and x coordinate for q is 3. Right, so x coordinate for p equals 1 and x coordinate for q is 3. Then B says the finite region R shown shaded in figure 1 is bounded by C1 and C2. So yes, this is the region R and this are bounded by C1 and C2, and we have to find using algebraic integration to find the exact value of R. So we can find the value of R by just integrating. So if we integrate the curve C, right, this curve C2, okay, this curve C2 from 1 to 3, we will get the area under this curve, right, this whole area. This whole area we'll find if we integrate the curve of C2 from 1 to 3. But again, if we integrate the curve C1 for the same values of for the same limit of 1 to 3, we will find the graph under the curve of C1, which means this area. Now to find region R, we can just simply subtract the area of C2, the area of C1 from C2, right? So we can just write that C2 minus C1. Okay. Now we can just integrate them separately and then just subtract them from each other. So that would give us. So first we need to find the integration of the curve C2. C2 has the equation 13 minus 9x squared. Therefore, for P, integration of from 1 to 3. I think this color is not that much visible. I'll just use another color. Let's use this one, deep one. So P, integration of 1 to 3 of C2, which is 13 minus, what was it? 13 minus 9 by x squared. So 13 minus 9 by x squared dx gives us, this can be written as 13 minus 9x minus 2 x to the power minus 2 dx. Now this is actually 13x. This becomes what the integration will be, minus plus 1 plus 1, x would be x to the power of, x to the power x to the power of minus 1, and we have 9, and denominator would be minus 2 plus 1 is minus 1, which is why we wrote plus. So we don't need anything for the denominator. Okay, so this is our required, this is our integral result, and the limits are from 1 to 3. So putting these limits, 13 times 3 plus 9 by 3 minus 13 plus 9, this gives us what? 13 times 3 is 13 times 3 is 39. 39 plus 3 3s are 9, so 3, and minus 13 plus 9 is 22. So just calculate 39 plus 3 minus 22 gives us the value 20. So 20 units, right? Unit square. Again, for the curve C1, we need to integrate C1. So C1 is x squared plus 3. Now integrate from 1 to 3, x squared plus 3 dx. This is x cubed over 3 plus 3x. 3 lags a little bit. So this is 3 and 1. So 3 cubed is 27 divided by 3 plus 3 3s are 9 minus 1 by 3 minus 3. This is 3 9, right? 3 9s are 27. So 9 plus 9 is 18 minus 3 minus 1 over 3. 18 minus 3 is what? 15. 15 minus 1 over 3 is, so 15 minus 1 over 3 will be 44 by 3 unit square. Now we just subtract the value of what? Subtract C1 from C2. So C2 was 20 and C1, so I can just, for clarification, area under C2, and this is area under C1. Area under C1. Therefore, area of R would be 20 minus 44 by 3. So 20 minus answer gives us 16 by 3 unit square. Answer. Done. Moving on to the next question is question 9. Here, this is a trigonometric question. So show that the equation 2 tan theta plus 3 cos theta can be written in this form. Okay, so we have to convert all of this into sine, since all of them are sine. So we can write 2 tan theta equal to 3 cos theta. This is A. Tan theta can be broken down into 2 sine theta by cos theta equal to 3 cos theta. Now if we take this cos theta here, this will give us 2 sine theta equals to 3 cos square theta. Now we can convert the cos square theta into sine square theta. We know that sine square theta plus cos square theta equals 1. Therefore cos square theta is 1 minus sine square theta. This is 2 sine theta equals 3 minus 3 sine square theta, or 3 sine square theta plus 2 sine theta minus 3 equals 0. This was what we are supposed to find, and this is shown. Then for B, hence solve this equation. So here you can see that this value 2x plus pi by 3 we can consider it as theta. So let theta equal to 2x plus pi by 3. If we do this, then this whole equation is similar to this equation, right? It's similar to this equation. So here we can write for B, let theta equal to 2x plus pi by 3. Therefore the equation becomes 2 tan theta equals to, well, 2 tan theta equals to 3 cos theta equal to 3 cos theta. Now from part A, we found that this value can be written as this. Therefore, we can write 3 sine squared theta plus 2 sine theta minus 3 equal to 0. Now we solve this quadratic equation. So for this, we can, what can we use? We can use the equation, like the equation x equal to minus b plus minus root over b square minus 4ac by 2a. So here b is 2, therefore minus 2 plus minus root over 2 to the 4, 4 minus 4a is 3, and c is minus 3, all divided by 2a, which is 6. This will be minus 2 plus minus root over 4. So this is 4 3s are 12, 12 3s are 36, and minus minus is plus. 36 plus 4 is 40 divided by 6. So one value of sine theta will be minus 2 plus root 40 by 6, while another value for sine theta will be minus 2 minus root 40 by 6. This gives us minus 2 plus root 40 divided by 6 gives us 0.721, and here it gives us minus 2 minus root 40 divided by 6. This gives us minus 1.387. So since this is less than minus 1, we know that the maximum value, and we know that the maximum and minimum value for sine theta is 1 and minus 1. So since this is much more less than minus 1, this value is not applicable. So we will only use this value. So therefore, we can find that theta will be equal to sine inverse 0.721, and this is, so sine inverse 0.721 gives us, okay, we were asked to find it in the range of from minus pi to pi, so that means we have to do this in radians, right? We have to find out the values in radians. So this, okay, let me change my calculator settings to radian, and then sine inverse 0.721 gives us 0.805. Now we knew that we made theta to be equal to 2x plus pi by 3, so just put the value here. So 2x plus pi by 3 will be equal to 0.805. Therefore 2x is 0.805 minus pi by 3, that is minus 0.242, and therefore x is divided by 2, that means minus 0.121. Now this is in the range of the negative values. Now we can also increase further. So sine is positive in the here in the first quadrant, sine is positive, and also in the second quadrant. So we can find this by just doing pi minus 0.805, right? And this value will be positive again after this. So 2 pi plus, we can also do 2 pi plus 0.805, right? So since this makes a complete revolution, so this is 2 pi, and then if we increase any value further than this, so it will be 2 pi plus this theta. So for these values as well, we can find out x. So here 2x plus pi by 3 will be equal to pi minus 0.805, and therefore x will be, let me just do it in shortcut. Okay, so alright, so for this we will get the value of 0.645, and for this one here 2x plus pi by 3 equals 2 pi plus 0.805. For this, the x value is 3.02. I think that is it, right, Naki? Or maybe we can find another value. Okay, so we have, this is up to positive pi, right? But we also did have the range for negative pi, so from negative pi to pi. So we can, I think the lowest negative value is minus 0.121. That is not enough. We can go further. So for sine to be much more negative, right, we can right, so if we rotate, like this is the value, if we rotate clockwise, right, if we rotate clockwise, we can find this value. So this will be negative pi plus, right? So this value, this from here, this value will give us another value, which will be, okay, well, we don't have much space. Another value that we can find for sine, that for this theta, would be 2x plus pi by 3 equals negative pi plus this 0.805, right? Since this is pi plus 0.805, but in the clockwise direction, therefore it's negative. So for this, the x value would be minus 2.50, and so these are the 4 required values. This is answer, this one is another answer, this one as well, and this one. Okay, we have 4 values in the range of from negative pi to pi. I hope you understood the question. This is a little bit tricky to rotate it clockwise to find the negative values, but since we have the range in negative, we have to do this. And this is the end for question number 9. I will see you again for the solve students to the solution for question number 10. So 10 says the circle C has equation of this, and we have to find the coordinate of the center of C and the exact value of the radius of C. So we know the general equation for a circle. So the general equation for a circle is what? X minus a whole squared plus y minus b whole squared equals to c squared, right? Where the center is a and b, and the radius equal to root over, not root over c, it would be only c, right? It's only c. Now for this equation, we don't have the equation in this form, so we can actually make it in this form. So we can write, so for a1, x squared plus y squared, the given equation is this, plus 4x minus 30y plus 209 equals 0. So from here we can take the x terms at one side, so x squared plus 4x plus y squared minus 30y will be equal to minus 209. Now if we do completing squares for this 2 and this 2, the completing square will give us, so x plus 4 by 2 whole square minus 4 by 2 whole square plus y minus, right, y minus 30 by 2 whole square minus 30 by 2 whole square, and this is equal to minus 209, or x plus 2 whole square minus 4 plus y minus 15 whole square minus 15 square equal to minus 209. Therefore x plus 2 whole square plus y minus 15 whole square equal to, so minus 209 plus 15 square and plus 4 gives us 20. Is this right? Minus 209 plus 15 square plus 4 gives us 20. So this is the equation in this form. Therefore our center is what? Center is in -2 and 15. These are the coordinates. This is our answer. And for number 2, our radius is equal to what? Root of this. So root of 21. Answer. So root of 20, sorry. Also, you can write it in the form like 2 root 5, and you can give units. It's the same result. Now for B, it says that the line L has equation y equal to mx plus 1, where m is a constant, given that L is the tangent to C at the point P. So show that. We have to show this. Okay, so we already know the equation of the circle, right? We already know the equation of the circle, which is x plus 2 whole square plus y minus 15 whole square equals 20. Now we know the equation of the line is mx plus c, so we can just put the value of y. Since it's tangent, it touches the circle. That means for that point, we can input the value of y for this line into the equation of the circle. So we can write x plus 2 whole square plus, in place of y we write mx plus 1 minus 15 whole square equals to 20, right? Mx plus 1 it was, right? Yeah, mx plus 1. So we need to just simplify this now. So x plus 2 whole square plus mx minus 14 whole square equals to 20, or x square plus 4x plus 4 plus m square x square minus 28mx plus 196. 14 square is 196, and this 20 if brought here, so it's minus 20 equal to 0. So simplifying this further will give us, so if we take x squares to be common, so x squares to be common, it is 1 plus m square plus x. If we take x as common, then we have 4 minus 28m, and the rest is 196 minus 20 is 196 minus 20 plus 4 is 180 equal to 0. Now we have a quadratic equation here. This quadratic equation, so since this is a tangent, right? So this, since this is this line is a tangent to the curve, to the circle, we will already know that b square minus 4ac will be equal to 0, right? B square minus 4ac will be equal to 0. So from here we can directly put this, since the line is a tangent, so b square minus 4ac equal to 0, or what is b? This, so 4 minus 28m whole square minus 4, 1 plus m square times c is 180 equals 0, right? Further simplification is, if we simplify this, break down 16 minus 2 times 4 times 28 is 224m plus 28 square is 784m square minus 720, 4 times 180 is 720, and minus, and again minus 720 m square equals 0, or 64m square minus 224m minus 704 will be equal to 0. If we like simplify it further, we can take 32 common, and so it will simplify to 2m square minus 7m minus 22 equals 0, right? So this comes from here, like we take 32 common, right? So we divide the whole thing by 32, and we have this. This is our what we were supposed to show, right? It matches perfectly. Then for C, hence find the possible pairs of coordinates of P. Okay, so we have to find the coordinates of P. So for that we need the value of M, right? We need the value of M. So for C we solve this equation. So again M will be equal to minus B plus minus root over B square minus 4AC all divided by 2A. And okay, so this gives minus b is 7 plus minus root over 7 squared is 49 minus 4 into 2 into c is minus 22 divided by 2 times 2. This is 7 plus minus. Okay, so you can do this with your calculator. So this will give us two values. The values will be 11 by 2 and minus 2. These are our two values for m. Now if we put the value of m in the actual equation here, in this equation here, right? Where was it? This is x plus where we can put here this in this equation, the main equation. We will get the value of x, right? We will get the value of x. So putting m equal to 4, so we have two m values of we have to find for each. So for m equals 11 by 2, we can write that what x square, what was it, 1 plus m square, right? 1 plus 11 by 2 square plus it was x 4 minus 28 into m. Okay, so plus 4 minus 28 into 11 by 2 x, and then plus 180 equals 0. So or x square times this will give us 125 by 4 plus, so this is actually minus, so 4 minus this will give us minus. Let me erase this. So minus 150x plus 180 equals 0. Or simply again doing the quadratic formula, using the quadratic formula, we can find, so x equal to 150 plus minus root over 150 square minus 4 times 125 by 4 times 180 divided by 2 times 125 by 4, and this gives us the value of the positive value of 12 by 5. We ignore the negative value since x is to be positive. Okay. Okay, yes. Okay, so this is the positive value. So and then we can find out the value of y using y equal to mx plus c equation. So 11 by 2 x plus 1, and therefore 11 by 2 times 12 by 5 plus 1 gives us 71 by 5. Therefore the coordinate of p, one coordinate of p is 12 by 5, 71 by 5. Again we have to do the same thing for m equals to minus 2, and again if you put the value for m here, so 1 plus minus 2 square plus, was it plus? It was plus 4 minus 28 into minus 2 x plus 180 equals 0, and doing this we will get, and solving this we get, so you in exam you have to do the entire process. I'm just, for the sake of the video, I'm just doing this in shortcut, but you have to show the workings properly. Show working, okay, show working, don't write this what I've just written. So this would be, so x will be equal to minus 6. Yeah, so x will be equal to minus 6 for this value, therefore y will be equal to minus 2x plus 1. So minus 2 times minus 6 plus 1 is 13. Therefore we can find another value for p is minus 6 and 13. Okay, so these are the two values. This is the answer, two coordinates actually, and this is the answer. Yep. Also, you could have taken both the values. So you could have taken, so this is for 150 plus, you could have taken another value for 150 minus, and that value will give another value for y, right? And that value will give another value for y. So you can actually write two separate, like you can actually write 4 coordinates, but since the mark is, how much was it for C? Since the mark is only 4, it's alright if you just write 2 coordinates, okay? But to be on the safer side, you can write 4 coordinates, so there will be 2 further more values for this, another value here and another value here. Moving on to question 11, it said that prove by counterexample that this statement, if n is a prime number, then 3 to the power of n plus 2 is also a prime number. Now we have to prove this statement as false. So this statement says that if n, any value of n, is a prime number, so say if n, say 3, n equals 3, so if 3 is a prime number, then 3 to the power of 3 plus 2 must also be a prime number. So here we can see that for n equal to 3, so let's just do this. You have to do this by trial and error method. So say n equals 3, for that we will get 3 to the power of n plus 2 will be equal to 3 cube plus 2. We know 3 cube is 27. 27 plus 2 is 29, and this is indeed a prime number. But does this continue? So for n equal to 4, we can see that 3 to the power of 4 plus 2 will be equal to, so what is 3 to the power of 4? 3 to the power of 4 is 81. 81 plus 2 is 83, and this is also a prime number. But for n equals 5, we can see that 3 to the power of 5 plus 2 is, so 3 to the power of 5 is actually 243. 243, now plus 2 is 245. Now this can be divided by 5. This is divisible by 5, so we can say, so if it is equal to 5 times 49. So since this is divisible, that means this statement does not hold true. It holds true for n equals 3 and n equals 4, but it does not hold true for n equals 5. Therefore, this statement is not true, or this statement is false, and we've proved. In this type of questions, you have to do this by trial and error method. So let's just try to take at least like the first 5 values. Okay, if it holds true for 5 consecutive values, then it's probably correct. But so for 2 marks, it's not that hard. So we can see that here in the third trial, we found that it to be incorrect. Now for question 2, use proof by exhaustion to prove that if m is an integer that is not divisible by 3, then m squared minus 1 is divisible by 3. Okay, so we have to find that m is an integer, any integer, 1, 2, 3, any integer, and that is, and this m is not divisible by 3. Okay, m is not divisible, sorry, so m is not divisible by 3, then m squared minus 1 will be divisible by 3, and we have to prove it. Okay, let's try. So say m is any multiple of 3, so if m is any multiple of 3, that is not divisible by 3, right? That is divisible by 3. So say m is any multiple of 3 but plus 1. So if 3x is obviously multiplied by, is divisible by 3, but 3x plus 1 would not be divisible by 3. So we take any value that is not divisible by 3. So 3x plus 1, if we take 3x plus 1, we can see if we input the value of m in this equation, so 3x plus 1 whole square minus n will give us 9x square plus 6x plus 1 minus 1, and this is 9x square plus 6x, and we can take 3 common from them. We can take 3 common, and this will be 3x square plus 2. So this is definitely divisible by 3, since 3 is coming out as a common factor. Therefore this is divisible, right? This is divisible by 3. So this is correct. Again, we can take another value for m equals, say, 3x plus 2. For this, 3x plus 2 whole square minus 1 gives us 9x square plus 3 to the 6 is the 12x plus 4 minus 1, and this is 9x square plus 12x plus 3. Again, we see that we can take 3 out as a common factor, so this will be 3x square plus 4x plus 1, right? This is definitely divisible by 3. This is definitely divisible by 3. So again, it holds true. Now let's try again. So we cannot take 3x plus 3 because 3x plus 3 will just is again, we can for 3x plus 3 it would be plus 3, it would be obviously divisible by 3, and we can take 3 common, but we will not take that. So we will take for m equal to 3x plus 4. For this, 3x plus 4 whole square minus 1 is equal to 9x square plus 3 to the 6, 6 4 the 24, 24x plus 16 minus 1 equals 9x square plus 24x plus 15. And again, we see that this entire polynomial can be it has a common factor of 3. So 3 common, 3x square plus 8x plus 5, and again this is definitely divisible by 3. Divisible by 3. Therefore, this holds true again. We will do one last time. For m equals 3x plus 5, right? We will do one last time. So for m equals 3x plus 5, we see that 3x plus 5 whole square minus 1 gives us 9x square plus 6, 6 5 is 30, 30x plus 25 minus 1, and 9x square plus 30x plus 24. And again, we can take out 3 common, so it becomes 3x square plus 10x plus 8, and this again is divisible by 3. So for all the different values for m that we have taken which are not divisible by 3, we have found that this equation holds true. Therefore, we can write that this is proved. This is proven. What? We've proved that m square minus 1 will give us a value that is divisible by 3, right? Okay. So this question is a little bit type of like it's mostly like an IQ type question where you have to use your analytical skills to solve this question. There is no rule book for this type of question. And so this is the end for question 11, and I hope you understood my previous videos. This will go down as a playlist.